In this video, we're going to be going over page 1 of the study guide for Math A. So the first question asks to find 12 and 7/800ths plus 9 and 3500ths plus 4 and 700ths. Recall that when adding or subtracting decimals, we want to line up the decimals. So line up the decimals. So what do we mean here? We mean this. 12 and 7/800ths. 9 and 30. So decimal point needs to be lined up. Once we've done that, we can go ahead and add. So 8 plus 5 is 13. 13 plus 7 is 20. Put down the 2, carry the 0. 2 plus 7 is 9. 9 plus 3 is 12. Put down the 2, carry the 1. The decimal point will come straight down. 1 plus 2 is 3. Plus 9 is 12. Plus 4 is 16. Bring down the 6. Bring the 6, carry the 1. 1 and 1 is 2, or 10 and 10 is 20 actually. So 26 and 20/100ths, which is the same thing as 26 and 2/10. So I'm subtracting. Let's see if I can get some better light on this. So now I'm subtracting 23 and 76/100ths minus 12 and 57/100ths. Again, when adding or subtracting, line up the decimals. So I have 23 and 76/100ths minus 12 and 57/100ths. Decimal points will just come straight down. And I just proceed as I normally do with subtraction. So 6 minus 7, I'm going to have to borrow from 7. 16 minus 7 is 9. 6 minus 5 is 1. 3 minus 2 is 1. And 2 minus 1 is 1. So there's my answer, 11 and 19/100ths. Let's go ahead and highlight this as well. Next up, find the product of 4 6 times 8. Remember, this is the same thing as 8 over 1. And now I see I'm multiplying, I can see it as I'm multiplying two fractions. I can go 8 times 4 is 32. 6 times 1 is 6. And now I simplify, so 32 divided by, how many 6's can you get out of 32? I can get 5, because 5 times 6 is 30. That means I have 2 left over. And this can be further simplified, because both of these can be divided by 2. I can also consider this problem this way. So I have 4 times 8, so I'll use a dot instead of multiply. And I have 6 times 1 is 6. Well, I have some even numbers here, so let's break this apart. The bottom is the same thing as 2 times 3. And then on the top, I see the 4 can be written as 2 times 2 times 8. Well, now that I've done this, I see that I've got a 2 on the top. Everything's being multiplied, a 2 on the bottom. Now, as long as everything's being multiplied, you can go ahead and cancel. So that means I have 16 on the top and 3 on the bottom now. 2 times 8 is 16. How many 3's going to 16? Well, I get 5, and I have 1 left over. So you see I get the same answer, and by simplifying first, I avoid the reducing the fraction. Next problem. Find the quotient of 9 6/10 divided by 0 and 4/100ths. So what they're saying is I need to do this problem. 9 6/10. Oops, I need to move it over more. Matter of fact, I'll write here first. So I'm going to divide 9 6/10 by 4/100ths. So recall that when you're dividing by decimal numbers like this, if your divisor has decimals, you have to move them over. So I'm going to move this over once, twice, so that this becomes 4. Now if I move this decimal over 2, I have to move this decimal over 2 once, twice, and I'll fill in any blanks that were 0. So I'm going to be dividing 4 into 960. So 960 divided by 4 is the same thing as 9/16 divided by 4 hundredths. Now I just need to do my division. How many 9s? 4 is going to 9. Well, I get 2. 2 times 4 is 8. 9 minus 8 is 1. Bring down the 6. How many 4s go into 16? Well, 4. 4 times 4 is 16. That's 0. So this 0 needs to come straight up. So the answer here is 240. There's my answer. Now I have 8/3 divided by 4/9. I'm dividing by a fraction, and I can employ the old keep, change, flip rule that we practiced many times. So the 8/3 stays the same. I'm going to change the division into multiplication, and I'm going to flip the divisor. So I can see that I have 8 times 9 is 72. 3 times 4 is 12. Now if I know my 12s times table well, I know that 6 times 12 is 72, so 72 divided by 12 is 6. But if I wasn't so sure, and I didn't want to deal with such larger numbers, I could rewrite this problem. 8 is the same as 2 times 4, and 9 is the same as 3 times 3. If I do that, now on the bottom I have 3 times 4. And I could see that I've got 1 3 on top and a 3 on the bottom. I've got a 4 on top, and I've got a 4 on the bottom. Those will all cancel out. Cancel, 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 cancel. I'm left with 2 times 3. 2 times 3 is 6. Number 6, you owe your $12 to your mom you borrowed. What integer represents the situation? So integers. So here's 0. If I started counting, I go 1, 2, 3, and so on. 4. And if I went the other direction, I would have -1, -2, -3, and so on. These are my integers. It does not include the fractions. So an integer is just a type of number. Now, 12, if I owed 12, what would make more sense? 12 or -12? Most people are going to say owing 12 is like saying -12 would be the integer for owing $12. Compared to if I have $12, it's not money I owe. If I have $12, people probably say that's +12. So in this case, the answer should be -12 because I owe it. The integer to represent it would be -12. Number 7, write an expression. So my answer is going to be an expression. Oh boy, that's smeared terribly because the printer I printed this out on. Using the distributive property to represent the total area of the figure. So here's my figure, and I'm not supposed to find the total area. Recall that the distributive property is this idea. When you have, say, 3 times 4 plus 5, this is the same thing as 3 times 4 plus 3 times 5. So I distributed the 3 across the two numbers on the inside, and I kept the sign the same, the operator. So 3 times 4 is 12. 3 times 5 is 15. 12 plus 15 is 27. Well, if I simplify the left side, I see that 4 plus 5 is 9, doing my order of operations, and 3 times 9 is 27. But this is my distributive property, this rule here. So if I look at my figure, I want the total area, and I can see that this whole length here is from here is 7, here is 2, so the whole length is 7 plus 2. and the width is 3. So there is my distributive property representation. 7 plus 2 is 9. So 3 times 9, 27. Next up, units squared. Let's remember that. Units squared. Because recall that area is always a square measure. So it's going to have the exponent of 2. 8. Find the greatest common factor of 36 and 90. Well, in order to do this, one way we can do is just list the factors. So what numbers can I evenly divide into both of these? So I'll do 36 first. Well, 1 times 36, I can divide those into 36. And now I'm just going to go up by checking 1, then 2. And 2 works because it's even. So 36 divided by 2 is 18. So 36 goes to 1, 18 goes to 2. And I know that 3 also works. And 36 divided by 3 is 12. It's also a basic fact, right? And there's also the divisibility rule for 3's. Will 4 work? Yes, it will, because when I divided it by 2, I got still an even number. And also, 4 times 9 is a basic fact. 5 does not work, but 6 will. 6 times 6. Notice how the numbers came together. After 6, I'm just going to get these larger numbers again, so I'm done. Now I need to do the same thing for 90. Well, again, whoops, not 19. 90. Well, I know 1 and 90 are going to work. And this is even, so I know 2 is going to work. So 2 and 45, half of 90 is 45. 90 and 1, 45. Will 3 work? Yes. 9 is divisible by 3, so 90 is divisible by 3. So 3 times 30. Will 4 work? No, because when I divided it by 2, I got an odd number, so I didn't bother checking for it. But 5 will work. 5 times 18. 6 will work because 2 and 3 work. So I have 6 times 15. And 7 won't work, 8 won't work, but 9 times 10. I ran out of room there. So that's 10 times 9. So here's all my factors of 19. And I see what's the largest number that's in each pile. Well, it looks like I've got an 18 here, and I have an 18 here. Greatest common factor. Greatest common factor of the GCF is 18. That is my answer. Find the missing number. Well, it's a little bit of a challenge to see this right here because 92 and 23 aren't necessarily numbers that we have in our basic multiplication. But I can see that I can reduce this. And maybe that's going to be my hint to find out here. So if I divide 72 by 2, I get 36. If I divide 92 by 2, I'm going to get 46. And I can do it again. If I divide this by 2, 46 become 23. Hey, that matched up. And if I divide 36 by 2, I get 18. So that means the missing number here is going to be 18. There's other ways, but in this case, that worked out well. Write the fraction in simplest form. Okay, so can this be reduced? Yes. I can divide top and bottom by 2. When I do that, I get 7 over 21. And I can still divide. I can divide the top by 7, and I can divide the bottom by 7. So 7 divided by 7 is 1. 21 divided by 7 is 3. And that cannot be reduced. Write 7 and 7/9 as an improper fraction. Remember that requires you to multiply the denominator times the whole number. So I'm going to multiply those two, and I'm going to add the number on top. So 9 times 7 is 63. 63 plus 7 is 70. 70/9. So 70/9 is equal to 7 and 7/9.